3/4 of a cake fits into 1/2 of the box. How much of the box is filled by one cake? This is 1/2 divided by 3/4, where we're asking ourselves a how many in one group type question. So we have 3/4 of a group times some quantity equaling 1/2 of a box. So 3/4 of a cake equals 1/2 of the box. So the missing quantity is how much of a box per cake, per one cake. All right, if we solve this problem through the invert and multiply algorithm, then we take 1/2 divided by 3/4. We keep the 1/2. We flip the second fraction, and we change the operation to multiplication. Multiplying across the numerators, we get 4. Multiplying across the denominators, we get 6. And if we reduce this, we get 2/3. So we see that 2/3 of the box is full if we put in one cake. All right, this is the invert and multiply algorithm. But we can visualize this math in several different ways. One way is to imagine a table. If we have a table, we could look at the amount of cake that we have and the amount of the box that we filled. We were told that 3/4 of a cake fills 1/2 of the box. If we divided our quantity of cake by 3, we would know how much 1/4 of the cake takes up by dividing the other side by 3 as well. So now we see that 1/4 of a cake fills 1/6 of the box. If we multiply by 4, then we'll know something about one cake. When we multiply both sides by 4, we see that one cake fits into 4/6 of a box, which we reduce to 2/3. So one cake fills 2/3 of the box. And you can see that we divided by 3 and multiplied by 4, which is the same thing we've done in the standard algorithm, invert and multiply. We're divided by 3 is equivalent to the fraction of multiplying by 1/3, and then multiplying by 4 is the numerator of 4, because we just multiplied by 4. Another way of visualizing this example would be through an area model. For the area model, we can imagine what our box looks like. And we can tell ourselves about the size of 1/2 of the box. So we know that we have 1/2 of our box. And in the yellow, we have the quantity of 3/4 of a cake. If we were to examine the numerator of the 3/4 of the cake, we could see that in this yellow portion, we actually have 3 pieces, each of size 1/4 of a cake, which I'll label with a little C. Well, we might think that's a cup, so I'll call it CK. So we divided our 1/2 of a box by 3 to get 1/6 of a box. We divided our 3/4 by 3 to get 1/4 of a cake. When we extend these cut marks, then we can see the 1/6 of a box holds 1/4 of a cake. In order to have a whole cake, we want to multiply our 1/4 size piece by 4 so that we could have 4/4 of a cake, which is 1 cake. By multiplying by 4, we need our original yellow pieces and 1 more piece. So we'll put this green piece in. Now we have 4/4 of a cake, forming a whole cake, and that's taking up the space of 1/6 times 4 parts is 4/6 of our box, which reduces to 2/3 of a box. So for a third time, we can see that when we divide by 3 and multiply by 4, just like we did on both sides of our table, just like we did in our invert and multiply algorithm, that we get 1 cake fits into 2/3 of a box.